Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you learn about AWS services. Today, we are going to talk about how to build a federated data lake in AWS. And we'll talk about what are the different design aspects or design elements you should consider when you're trying to build a federated data lake in AWS. This is again one of those tutorials where I'm not going to show you any demo or I don't have any lab for the practice, but I'm going to talk more from the design and architecture point of view. So let's get started. Before we jump onto the core of topic, let's try to get some of the definitions straight. Like for instance, what is data lake, or what is centralized data lake, what is federated data lake. Let's set those terms fixed first, so that when we talk about things, we have a common understanding between us. So let's talk about what is a typical data lake. And a typical data lake will have various components. So for instance, you will have various data sources from where you want to actually ingest your data into your data lake. And in order to ingest your data, you write different data ingestion pipelines. And these data ingestion pipelines actually bring your data from data sources to the raw data area of the data lake. And then once you have data in the raw data area of the data lake, then you write certain transformation pipeline, and these transformation pipelines are then responsible for turning this raw data into cleans, and then also turning this cleans data into curated. And difference between raw, cleans, and curated is that raw data is like when you bring data from your data source, whatever format the data comes, you don't change that format so that it has a traceability back to the data source. And for that stage is called raw data, and raw data is immutable. You don't touch it, you don't change it. But then your raw data might need certain cleansing, like standardizing on the date format, currency, standardizing on a data format, fixing the missing values, null values, duplicate values, things like that. And when you write certain transformations for that kind of cleansing, then your data turns into a cleansing data. And then from cleansing data, you create curated data or consumable data or harmonized data. And this is a data which is primarily used by your end users. So your end users convert your cleans data into curated data using certain data transformations, and they create curated data based on their business needs, based on what they want to do with the data. Now, and all these things are done by data transformation pipelines. Then your data needs to be cataloged across raw, cleansed, and curated. And then you need to provide data access control. Not everyone can access all the data. So based on who has authority to use what data for their business purpose, you provide a data access control. And then comes your consumption part, where your data can be used for reporting or dashboarding purposes, or it can be used for machine learning purposes. There could be more use cases as well, but I'm just listing down two top use cases, which is primarily reporting, dashboarding, and machine learning. Now, this is what a typical data lake look like. So when I say data lake, this is what I mean. These are the functionality, or these are features is what I mean. Now, just to map this data lake from architecture point of view, and again, I have covered this into many of my other videos about data lake, but I just want to take a snapshot of the architecture again using AWS services. That how does the data lake architecture look like if you're trying to build a data lake using AWS services. So for instance, again, mapping to the same set of components, you will have different type of data sources, which could be your JDBC endpoints, APIs, your IoT devices, file systems, you name it, right? And then you will use different services like Glue, Lambda, Kinesis, IoT, data sync, to build pipelines to bring data from these data sources to the data lake. Now in data lake, again, your data is in three formats, like raw data, cleansed data, and curated data. And generally you try to keep your raw and cleansed data in Amazon S3 bucket. But when it comes to curated data, you can have your data in Amazon S3 bucket, or you can also keep it into Amazon Redshift cluster if your data is more into like is more of a warehouse kind of data. Yeah. So depending on your performance requirement, depending on your data model, in the curated layer, you can decide whether I want to keep my data into S3 bucket or Amazon Redshift. And again, a certain set of services like Amazon AWS Glue Job is used to create all kind of data transformation pipelines. Glue crawler is used to catalog the data, and then AWS Lake Formation is used to provide access control to the data. Then when it comes to consumption, and if I try to use AWS services end-to-end, if it's a reporting or dashboarding requirement, then you use Amazon QuickSight for creating reports and dashboard, and then you use Amazon SageMaker or SageMaker Studio if you want to use it for machine learning. So if you try to build a very high level, how to build this capability of data lake using AWS services, these are the top AWS services which come to use in order to build your data lake. Okay, just I wanted to give a perspective and then I want to move on. I'm not going much into building data lake today, but I'm more talking about building a federated data lake. So federation part is more important for the talk today. So talking about federated database, let's try to see what is a centralized data lake. And centralized data lake, as name suggests, it is a single data lake which is used by all the users. So all the users, if you have a centralized data lake, then generally you have all the users, all the data users within the organization using this single data lake for their use cases, for their business needs. It could be department 1, 2, 3, 4. It could be region 1, 2, 3, 4, anything. But basically, centralized data lake means you have a single data lake within the organization, and every data user is using this single data lake for their business needs, whether it's for reporting, dashboarding, machine learning, no matter. If that is the case, then it's called a centralized data lake. Pretty straightforward and simple. Now, what is federated data lake then? Federated data lake is when you have more than one data lake. It's as simple as that. Yeah. So centralized has a single data lake within the organization. Federated has more than one data lake within the organization. But just having more than one is not enough to define a federated. It should have one more characteristic. And that is that all these different data lakes, which could be 2, 4, 15, 20, depending on how big the organization is. But these data lakes should be connected to each other. That means user of a data lake can also access data of a different data lake. So though people have their own primary data lake where they can access the data of their use, but that does not mean that their access is controlled only to that data lake. If business need comes, they can access data from the other data lakes as well. So two things make a data lake federated data lake. One is that, of course, there should be more than one data lake within the organization. And second thing is that each of these data lakes should be connected to each other. That means user of one data lake can access user of other data lake. And again, who can access which data lake is again driven by your business needs. But yes, technically, federated data lake provides a federated access. That means it provides a user access to more than one data lake within the organization if that is the business need. So that's what a federated data lake is. And today we are going to talk about, if you're trying to build a federated data lake, what kind of different design considerations you should keep in mind. Okay, so moving on. So how do I decide whether I want to, and before I jump on to like thinking about elements of designing a federated database, let's state a few more things, like how exactly I decide whether I want to go for a centralized data lake or a federated data lake. A few talks on that. I'm sure that will be useful for you. And sometimes decisions are very simple. I mean, I might have an organization which is a small, mid-sized organization running in a single region or a country. I have very centralized operations. So I have organization like that, which is very centered, very focused, very centralized, not very big, and all I need is a small data lake. A small data lake there, and yeah, a small mid-sized data lake, and it's serving the requirement of my organization, because I'm not so big to have more than one data lake here, and one data lake is more than enough for me to serve my purpose. So this is, in this case, your decision is pretty straightforward. It's a small organization, centralized operations, go for a single data lake. But and giving just another example, for instance, what if you have a huge organization which is spread across multiple countries or the region, and your operation is completely decentralized? Yeah, literally. I mean, for instance, people in America, East Coast, they are separate in terms of operations from the West Coast, or from Europe, or from Asia. If that is the case, again, the decision is simple. That means you want to go for a federated data lake, where you have more than one data lake within the organization, spread across countries or the regions. And of course, these data lakes are connected to each other, though I'm not showing the diagram over here. So these data lakes are connected to each other. That means, suppose people working in Australia, they can have access to data in Asia or in Europe if their business need comes. So again, this is example where decision is very simple, because your organization is huge, is spread across the world, and the operational is completely decentralized. But sometimes you need to think, because it's not very clear in terms of whether I should go for centralized or decentralized or federated or mix of it. So one example will be, for instance, I have got a huge organization, multi-region, multi-country, decentralized operations, but I want to also have a centralized corp where some key decisions are made. So in this case, you can see, I have got, really my organization is widespread, but there is one region, one country, one headquarters, one corp which is bigger, which is central, which is the key decision maker. That means I have to go for a mixed model here. I want to have a federated data lake over here, but this data lake over here is kind of a centralized data lake, because this data lake needs access of data from any other data lake. So again, it's an example of a federated data lake, but one data lake is more powerful or much bigger than other decentralized operational data lakes. So this is where you might have to think a bit in terms of how I design my data lake. Do I need to have things like that. And then there are other scenarios where I have got huge organization, single country, but still decentralized. So literally, I mean, sometimes you have things like that your organization is big in a country, but your operations are literally decentralized even within one country. In that case, within one country, you can have literally multiple data lakes. So within one organization, one country, one region, you have multiple data lakes. And this is the case where though it is not a multi-region organization, multi-country organization, but organization is so big and departments are so decentralized that you need more than one data lake to serve the purpose. Yeah. So these are the cases where you have to think a bit. Otherwise, it becomes very clear whether you want to go for centralized or decentralized. It's primarily driven by whether your operation is centralized or decentralized. Now, there are certain factors which affect decision of centralized versus federated. And let's talk about that. And again, there could be many factors, but these four I generally see in my experience, so I want to discuss about that. The first one is your data. So the type of data different people trying to use, how much diversity is in that data. And again, I'm going to explain this in next couple of slides. So, but let's try to get a definition of these 4 points first. So first is data. So what different types of data people are using, that very much affects your centralized versus federated decision. What kind of different usage scenario you have? I mean, like I'm talking about use cases, or what kind of business needs people have. So business needs is another things which decides whether you need to go for centralized or federated. Then what kind of access control or security requirements these people have. I mean, some can say I have a very secure requirement, I want encryption and those kind of things. And well, that is still okay. But I mean, like, do you see that people are in such a way that different set of people needs literally a different access control on the data for their business needs, and that very much affects your centralized versus federated decision. And the fourth one is evolution path. Now, you might have a single data lake or 10 data lakes, but think of a scenario where you have more than one data lake, and one data lake is evolving very fast over other because of their business needs, type of business, business nature. That can disturb the whole organization in case of centralized. If you think that different people in different types of need for data lake might have different evolution path, and someone's evolution path can actually disturb other, then that very much affects your centralized versus federated decision. So basically what you do, you try to take these four things together and see how much common requirements I have across these four. So basically you're trying to see, okay, let me see my data requirements and my usage requirement and my access control and my evolution path. I take these four things together and try to see that how much is within my organization, how much is common here, and how much is common here determines whether you want to go for a centralized data lake or you want to go for a federated data lake. So basically we are looking for this cross section over here between data, usage, access control and evolution path to see how big is this cross section. Because bigger the cross sections, that means the requirements are common, and smaller the cross section, that means requirements are exclusive to different people. So if I try to use this way of deciding, I'm not saying this is the only way to decide whether you have to go for centralized and federated, but certainly I have seen this one in practice. But if you use this way to decide whether I want to go for a centralized or federated data lake, then your centralized data lake looks something like this, where your requirements within the organization, so there are different departments, different set of people who are working within the organization, but their data, usage, access, evolution path, it's lot common. Their cross section is quite big. So if you see that people have common data, usage, access control, and evolution path behavior, then you can say, oh wow, this is the case of a centralized data lake. But it could be that different set of people or different departments have literally mutually exclusive data usage, access control, and evolution path requirement. Like I showed in the second picture, the cross section is here. The cross section was very big because the requirements were very common. So it's good to go for centralized data lake because the requirements are so common. It doesn't make sense to have more than one data lake here. But sometimes the requirements are not common. The requirements are almost exclusive, or this cross section is very small. And in that case, you can say I would go for federated data lake because different set of people, groups, or departments have their different data usage, access control, and evolution requirement. And if people are one group of people requirement is so different from other set of people requirement, it makes sense to have different data lakes because then each can run their operation in their own way and evolve in their own path. So this is one method I have seen people using when they try to decide whether they want to go for a federated or they want to go with a centralized requirement. And if you are still confused, just hold your breath. I'll come back and talk about it. You're still confused that I can't decide whether to go for centralized or data lake, or my cross section is not that big, that small. I'm somewhere in between. Still, you can make a way out, and I will talk about that towards the end of the slide. Yeah, but keep in a way that if the common requirements are very are huge, there are so many common requirements, then probably centralized data lake make more sense. If the common requirements are very less, the requirements are very exclusive, segregated, then you want to go for a federated data lake. So now let's move on to what it takes to build a federated data lake. What are the key design elements you have to consider? And the first one is you need to have a multi-account AWS organization. So when you're talking about a federated data lake, we are talking about an organization which is big and which is a very much decentralized operation. And of course, this organization has got some kind of organization structure in place. And what you do actually, you try to create a multi-account AWS organization which maps to customer organization structure. So you create an AWS organization structure similar to customers, you create an AWS account structure similar to customers organization structure. And then each organization, each unit or each department within the organization have one AWS account of their own. So for instance, look at this one. So there's one organization which has got two departments, one or two which are operationally like decentralized departments. I will create one AWS account for both, and I'll put a AWS account structure like this. Now each of this department then can launch their data lake within their own account. So department 1 will simply go and launch their data lake within AWS account department 1, and department 2 will simply launch their data lake within AWS account department 2. So each departments can launch their data lake in their own AWS account. And their tagging of your resources becomes very important because you want to set up cost accountability. And in order to set up cost accountability, you have to do proper tagging of your resources so that based on the tag, your cost ownership can be identified. And there you can use AWS organization's tagging policy to enforce and regulate certain tagging on your resources. So having a multi-account organization like this, where each department within the organization have their own AWS account and they run their data lake in their own account, is the first step we see when you're trying to build a federated data lake. Now, moving on, once you have this federated data lake, I mean, people will have their own network-based, not non-network-based resources. So it becomes very important that these different networks running in their own AWS accounts, in their own VPCs, have a connectivity, because remember, the requirement is that in case of federated data lake, though I have my own data lake, suppose I'm in department 1, I have my own department 1 data lake, but if the business needs arrive, I can access data from department 2 data lake as well. And if I'm running, suppose, some kind of, say, virtual machine, EC2 instance out of a VPC, then I need to have a VPC connectivity to the other department AWS account or VPCs so that I can access the resources from there. So having a network connectivity between AWS account VPCs is very important. So for instance, here I have got my AWS account for department 1, AWS account for department 2. Both have their own VPCs, and these VPC needs to have a network connectivities between them. And generally, I mean, you can do many methods, but generally, if you're using latest of the AWS thing, then you might want to set up a network account. And in that network account, you can use AWS Transit Gateway to provide this transit connectivity between these two VPC. I mean, you can go for direct peering as well, but that's not advisable. If you want to build a scalable solution, then you should be using a transit gateway kind of solution to provide a connectivity between different VPCs running into different accounts. So this kind of connectivity should exist because I mean, like resources like Redshift, they run out of VPC, inside a VPC. So unless you have a VPC level connectivity, network level connectivity, you will not able to access Redshift kind of data from the Redshift kind of resources. Okay, so having network connectivity is a second very important element. Now, moving on. Now, one of the requirements, as I mentioned earlier as well, if you're trying to build a federated data lake, then basically department 1 user can access data from department 2 as well. And department 2 user can also have access data from department 1 data lake. And in order to ensure this seamless data access and everything, you need to work on an identity which works, which is like unique across the organization. I, as a user of department 1, cannot have one identity when I'm trying to access AWS account 1 data lake, but when I go to AWS account 2 data lake, my identity changes. If you're building if each account have their own identity, you are creating a nightmare for a federated data lake. So you want to actually work on an identity which is unique across the organization. And that's where AWS single sign-on really helps, because with AWS single sign-on, you can work with an identity provider, any of the identity providers. I don't want to name anywhere here, but any of the identity provider, you can provide federation or single sign-on with the root master account. And with that kind of single sign-on, suppose there is a department 1 user who wants to access the data lake in department 1, they can use the same single sign-on and single identity to access it. And if there's a department 2 user who wants to access data from department 2, they can also use the same single identity. So by providing single sign-on with your identity provider at the master level, and then extending that identity across all the AWS organization within all the AWS account within the organization, you ensure that your users are using the single identity, no matter they are accessing their own data lake or they're accessing data lake from some other department, some other organization within your organization, some other group within your organization. Okay, so having a seamless and unique identity across the organization is very important, and you can very much achieve that using AWS single sign-on based federation, identity federation, I mean. So moving on, so another very important thing is that when you're trying to build a data lake, your data cataloging is must. And why it is must? Because you are creating a federated data lake, and I am a user of a one data lake. I want to access my data in my data lake, but then I want to probably reach out to 3 other data lake to access data from there. And in that case, my data should be in a searchable, discoverable format. It should not be hidden somewhere in some database or some S3 bucket which no one knows. It should be cataloged somewhere so that I can go to that single one place and can see, oh, in this data lake, the following data is available, and this particular data I'm interested in, and I want to access to that. If you want that kind of searchability, discoverability, then you need to federate your data in the data lake. So every data lake running under the federated data lake system should catalog their data so that their data is visible, searchable, discoverable by all users within the organization. They might not have access to data. Like for instance, they should be able to browse the catalog. They should be able to see in a particular data lake what data is available. They might not have access to even query data, and that access they can request and get through an operational systems in the place. But what is important here is that each data lake should have their data cataloged and listed so that people can reach out to data lake and can see the data available under the data lake, and then simply make a request to access certain set of data depending on their business need. Again, as I mentioned earlier, that your unit of access is data lake is catalog now. So you don't give access to actual data. You give access to the catalog to the users, and then that gives access to the actual data. So I might be like, say, in marketing departments, I have my own data lake, but I suddenly need to get some data from sales department, and I want to know top 10 customers based on things sold to him. That data I want to access. So I need some way to go to sales data lake and then able to see the customers listed, customer catalog there, and then I can say, give me access to customer catalog, and then you might make a query to see which are my top 10 selling customers over here. Okay. So unit of access here is the customer data, and that access is so you need here access to customer data, and then customer access is given through this customer catalog in the sales database. Finally, needless to say, but you should be using AWS crawler to do automatic cataloging of the data, because when you're talking about a federated data lake, you're talking about huge data lake, multiple data lakes with probably having their own hundreds of catalog, and manually maintaining such catalog is not possible. It's not feasible. So use AWS Glue crawlers to automate such data catalog updates. Now, I did mention about using a single identity to access your data across multiple, across your organization, so or across multiple federated data lake. Now, how do you access control to such data lake? And that you can do using AWS Lake Formation. AWS Lake Formation provides features to give access not only to your own data lake, but it can also collaborate with other data lake to provide a cross data lake kind of cross AWS account, cross data lake kind of access. So your access should be managed through AWS Lake Formation based access for you to be able to get quickly operationalize cross data lakes access for your end users. Because again, if you're building a federated database, doesn't mean that you only access data from your own data lake, but you might need access of data from other data lakes within your organization. Okay, so moving on. Now, when you're talking about cross-account access, so like earlier I talked about, for instance, like using lake formation to configure the permission for access to data not within your own data lake, but to other data lake as well. And this cross account or cross data lake access is very much supported by AWS services, and I want to talk about now how they support it, so that you know how to technically enable that. So two storage mechanism primarily used in your data lake is keeping your data into S3 bucket or keeping your data into Amazon Redshift cluster. And both of these services, Amazon S3 and Amazon Redshift cluster, provide mechanism to enable cross data lake access or cross account access. So let's see how it works. So for instance, let's take a scenario that there's a department 1 which has got its own data lake. Department 1 users can, for instance, in this example, I'm using Athena as an example. They're using Athena to access their own data lake. Then there are department 2 users who wants to who are also accessing data in their own of their own glue catalog of the data lake using Athena, and all these local permissions of access is managed by, for instance, AWS Lake Formation in both cases. Now there could be a scenario where I'm saying that when department 2 users say I want to access from department 1 certain tables, and in this case you are talking about a cross-account data lake access, and this cross-account data lake access is enabled using AWS Lake Formation. So AWS Lake Formation has feature called external access, external catalog access, and using that external catalog access, you can enable users of department 2 to have data access to a data in some other data lake in department 1. And now this access doesn't mean that I'm copying this data from here to here. No, not at all. The data is still residing over here. I'm just providing a cross-account, cross-data lake access for department 2 users on a department 1 data lake for certain tables. Okay, so this is possible, which allows use AWS Lake Formation to do a cross-account catalog access. Now, there are scenarios where you have data, so that was like having data inside a catalog, but there could be a scenario you have data inside Amazon Redshift. And you are accessing your data, like for instance, the department 1 and 2 again. Department 1 has got their own Amazon Redshift, and then they are using local access over here, and department 2 is also having a local access over here. But there is a requirement where my department 2 might want to access some data from department 1 Redshift. In that case, you are talking about again cross-account data access in Amazon Redshift, and that is also possible, and that is possible through a feature in Redshift called data sharing. I created another video which talks about how data sharing works in Amazon Redshift. You might search about that video in channel. I'm not going to talk much about data sharing over here other than what it does, but of course there's another video you can see, and you can see demo as well over there for how data sharing works in Amazon Redshift. But basically what you're talking about here is that your department 2 Redshift can work as a consumer, and through this data sharing feature it can access data from department 1 Redshift, which then works as a producer. So through this producer consumer behavior, actually you can again, this Redshift cluster will have access to data from this Redshift cluster. So department 2 users using their own Redshift cluster can access data from another Redshift cluster in other account, other data lake. And that is possible through this data sharing mechanism. So that's another example how AWS services provide this cross-account data access, which is very critical for building a federated data lake, because you need to share your data in federated data lake. Just to make it very clear, when we are doing data sharing, again, we are not copying data from this Redshift cluster to this Redshift cluster. We are simply accessing it data from this Redshift cluster to this Redshift cluster without any data copy. So it's really very wonderful thing and very supportive to federated data lake architecture. Finally, one very important thing is that when you're trying to build a data lake, you're trying to build a data lake which enforces reusability and standardization. Suppose your organization decides to build five data lakes, and you don't want each data lake to be running with different standards, whether it's standard about your data structure, whether it's standard about your security configuration, access. You don't want difference, because if the data lakes are different, then your operational costs are going to increase very high. Plus, it's very hard to have a unified security across. There are many challenges which can come into place. So it's very important that you use a kind of a template-based model to build your data lake, so that all your data lake are following the same kind of standardization and configuration. So in this case, actually what you can do is that you can use infrastructure as a code method to build a reusable and standard data lake template, and these templates then can be used to launch any data lake. And this template you can build into AWS Cloud Formation or in Terraform or Ansible or CDK or any other technology. I really don't care. You can use any of the infrastructure as a code technology or service to build this kind of a reusable template, but try to build a reusable or standard template which can be used to launch each data lake, so that each data lake looks similar to each other in terms of configuration, security, standards. So what can go into this common template? And I want to give some examples, because generally people are saying, well, it sounds very good that I should have a template to build a data lake. But what exactly goes into this template? And let me give you a few examples. So for instance, you can have that this template will launch 3 S3 buckets for raw, cleansed, and curated data. Okay, so one example. So you're building a template which is simply going to launch 3 S3 bucket in your AWS account for raw, cleansed, and curated data. Now, all S3 buckets should be private, will be launched private. They will be by default encrypted, and then access log will be enabled on all S3 buckets. So certain security features on the S3 bucket as a standard. Then you're going to configure a standardized Redshift cluster configuration for curated data. So like having Redshift launched into a private VPC with restricted network configuration, having a very strict security group policy, having a Redshift role assigned to the cluster, which again provides a restricted access to the Redshift role. So those kind of standard Redshift cluster configuration you can create as a part of your template. Okay, then you can have, like for instance, I will have a pre-configured glue crawlers for all my existing S3 buckets. So you're already giving 3 S3 buckets, raw, cleansed, and curated. You will have a automated crawler configured to crawl and catalog the data stored into these 3 buckets. Now I can have certain reusable parameterized glue job or lambda functions for ETL purpose, which might be, for instance, you are trying to read data from database and store into an S3 location. You might create a parameterized glue job where this database name, table names, S3 location, connection information can be passed as a parameter, and it can simply do the ETL thing for you. And same goes for APIs and lambda functions. So literally in this template, you can have certain reusable parameterized lambda functions or glue job which can perform standard ETL operations. You can simply have standard data cleansing glue job. Suppose within your organization, across different departments, you have standard cleansing job defined. You format your date in a certain way. You format your currency in a certain way. If you have this kind of standard routines to perform across different departments. You might want to create a cleansing glue job, standard cleansing glue job, which can simply take care of this standard data cleansing operations. This can go as a part of your template. You can have standard pipeline workflows. If you think that certain part of the pipeline can be automated, can be standardized, you can create a workflow for that. You can create standard IAM roles to standardize how data is accessed or how services are accessed within the data lake. So you can create standard IAM roles. You can enable CloudTrail. You can enable Amazon Massey to see if there's no insecure PII data into your data lake. So you might want, if suppose you're dealing with customer PII information, then you might want to make sure that you have standard you have some kind of checks and balances in place as a part of a template which can identify the PII data and can send you alerts about that if the data is not secure. And similarly, you can also use AWS config to enforce compliance. So like I talked about, if the bucket's created without any encryption, or the buckets go public, or if CloudTrail is not enabled, you might want to create AWS config rules to check such compliance. So these things can become part of your data lake template, so that when a data lake is created, they are created with certain checks and balances and standards in place. And of course, after that, the team can extend. So of course, it's not because you created a data lake, because multiple data lake or federated data lake, because the users have different requirements. So of course, you want to provide a standardized way to operate or configure your data lake, but then the users of that data lake will simply extend this data lake post the base template as per their business needs. So as long as they are extending the template or their data lake within the security and compliance rules, it's perfectly fine. I mean, of course, each team will for sure extend their data lake beyond this base template to their specific user needs. So that's how you might want to standardize your data lake creation across across your organization, to make sure that data lakes are created with certain security and certain foundation and certain standardization in place. Finally, concluding, so these were some of the key design elements you have to think about when you're trying to create a federated data lake. Now, coming to the conclusion, and here I want to say that there are some cases when you are not sure whether you want to go for a centralized and federated, because to be honest, it could be very confusing when you're not sure whether really you know that you want to go for centralized or federated. If that is the case, to be honest, it's not a big worry. So it's not the end of the world. Yeah. So if you're not sure about centralized and federated, not a worry. You can always start with a centralized and then evolve to a federated one. Okay. So you can always start with launching a centralized data lake within your organization. So start centralized, start small, but then evolve it to federated if need, evolve in that direction. And in order to do that, actually what you want to do is first, you need to have a federated data lake foundation in place. So the key elements I talk about, having multi-account organization, single sign-on, using a template-based data lake, those foundation you need to have in the beginning, even if you're trying to start with centralized. Okay, so you have all those elements in place, design elements in place, foundation in place, and then with that foundation in place, you start with one data lake. You start with one data lake, call it a centralized data lake, and then over a period of time, as your needs evolve, as organization's needs evolve, you simply evolve to federated, become bigger and bigger. So again, if it is a scenario where you are not really sure about centralized or federated, have this federated data lake foundation or design elements in mind. You keeping that as your foundation, that is the base of your design. You create a centralized database. You create a small database. Start with it, not database, data lake. Start with that, and then over a period of time, you simply evolve to a federated database. That is also possible, and many organizations actually work like that. They want to start with a single small data lake, but then they have all the foundation in place to evolve to a federated data lake within their organization. So these were some of the fundamentals of building the federated data lake. Hope you liked the video, and if you like, please click on the like button and please subscribe to my channel. I always look forward to your feedback, whether you want to request for a new content, or you have any feedback for improvement, or you want to discuss any of the topic I presented about in my chat channel. You have any questions about that? Yeah, please feel free to reach out to me with your feedback, your questions, your suggestions in the comment section of my YouTube channel. I look forward to your comments. And I promise to come back again in a week's time with another video. In the meantime, stay safe and have a nice day. Bye-bye.